So to get the angle between two vectors, we can either use dot product or we can use cross product. So in each case, we can get the angle between the two vectors. So of course, in these expressions, theta here becomes the angle between our two vectors. But in this course, that is in 2110, in your mathematics, mathematicians are tending to prefer the use of cross product here. So we're going to use cross product to get the angle here. So of course, the vectors are already put there. So you should be able to just get their cross product. So we're just crossing them and then get the angle between. So you can look at V here as like in part A, V can be taken as 1, 2, not 1, 2, we're writing it as a vector now. So you can say this is I plus 2j plus 3k. And then we can take our U, this is actually U, put into that label. This is U, and our V. Our V is 2I minus 3j minus k. So that is our V. So now that we have the V and we also have the U, we now just have to cross them, get their magnitudes, and then sign the angle between them, work out for that angle between them. So this is how we'd get them. Are you guys comfortable getting the angle using this formula, or so that I leave it for you guys, or we do it still?
Right, we can take it on our own.
Okay, great. Now, what I wanted to point out is part B there. Show that the triangle with vertices P equals to that, Q equals to that, and R equals to that is a right angle, and find its area. That is perhaps what I would want to highlight here. How can you show that a triangle is right angled when you're given only its vertices? Well, any ideas before we start?
The angle between the.
Yeah. One way we can do this is by trying to find the angle between 2 points. Okay. So one way we can try to do this is by finding the angle between two points. So you can try them out, pair them up, try to find the angles between them. Once that fails, just keep trying. Try this, see the angle between them, try this set. Let me show you what I mean. See, I'll put this to be random, and it might look like it's 2D, but that is because I'm drawing on a 2D space, so that is okay. So let's say we have a triangle like this one. We have no idea whether it's right angled or not. I'll put point P to be here, point Q to be here, and I'll put point R to be here. Now, here, of course, we want to know, is any of these angles right angled? I'll say that is alpha. I'll say this is beta. I'll say this is gamma. One approach would be what you were saying there. Try to find the angle between two vectors using the method we described above, and see if the angle between them is one of them is going to be 90 degrees. So, of course, to use any of those methods, yes, Panache?
Chef, can I please ask?
Yeah, sure.
If it's like this, the whole triangle as it is, you're saying we need to find the angle, but we have to use all of those points and to like test an error until we find it. Sorry, I didn't understand what you're saying before. My phone was kind of dragging.
Okay. There are two methods we can use here, but either method we use is going to be a case of trial and error until when we actually find what we're looking for. So firstly, we can get the displacements. We can get PR, the vector PR. We can also get the vector PQ. Then next up, we can get the vector QR. It doesn't matter how we move anyway. QR. So these displacements I've labeled there, they describe this displacement, and this displacement. So they describe the displacement vectors there. Now, to determine whether the triangle is right angled, we have to see if in the first method, we want to see if any angle inside is going to be 90 degrees. If we can find either angle alpha, beta, or gamma to be 90 degrees, then we can argue to say that the triangle is actually right angled. See, we can start first by getting the angle between this and this. So in other words, we can start by checking if alpha is 90. So to check if alpha is 90, using cross product, can use dot product or cross product. Of course, we're just going to say PR cross PQ. We need the magnitude here only, then the magnitude of PR, the magnitude of PQ. And then sine the angle between them. The angle between them is alpha. In this case, what you will get is going to be alpha, and you want to answer, is alpha 90 degrees? If it is not, then that is not the right angle. That is not the angle which is 90. So we will have to check something else. We'll then get the same thing, but now we just swap the vectors we are crossing. So in the next part, we can then come and check, okay, maybe these two are not the ones giving you 90. What if it's these two? Meaning it is PQ and QR. So we're now trying to check if beta is the one that is 90. So in this case, we're checking PR, or they're not PR, PQ and QR. So PQ is there, QR. So this becomes QR here. And then here, of course, you can use them the way you label them. Here, this is QR and PQ, that's okay. This is QR here. Now, in this case, it's now sine beta. Have you seen that? So in this way, what we'd find is what beta is. And if we find beta also is not 90, what would happen is that, okay, maybe that is not the 90-degree angle we want, or they want, that makes this right angle. We can then try to check this and this, so that we see if the angle between them here is the one that is going to be 90. This is one method, but there is another method that we can use here. And that is the one that we're going to use to work out this question now. For this method, we're now going to use dot product. But before we even describe how the method works, let's find PR, PQ, and QR. So we have the coordinates. The coordinates here are P is 4, 3, 6. Q is -2, 0, 8. And then R is 1, 5, and 0. So if we're getting PR, that is going to be -2, -4. That's -6. The other is -2, -4. That's -6. Then we have 0, -3. That's -3. Then we have 0. Sorry, how does that? This is here. 0 -3 -3, 8 -6, which is 2. So plus 2K.
Getting the points for PQ.
PQ. Yeah. Sorry. So that's PQ. We need PR. So let's do PR. Oh, that's PQ. Let me just get this and put it where we have PQ. So let's get PR now. PR is going to be R minus P. So that's 1 - 4, which is -3. And then we have 5 -3, which is 2. And then we have 0 -6, which is -6. Next, we have QR. For QR, it's 1 minus 2, which is +2. And then we have, that's QR, so that's RIS. 5 - 0, that is 5. And lastly, we have 0 -8, which is -8.
My first one is 3.
First one is 3. That is 1 minus 2. Yes, that's +3. How did I write that too? Thank you for that. So we have obtained the 3 vectors. Now, the thing for this second method we want to see is we want to use one property of a dot product. See, if we have a vector v and another vector u, and then we dot these two vectors, if the vectors are perpendicular to each other, what will be the answer? Can you guess? What is the dot product?
Yes.
Yeah, go ahead.
Left.
The dot product of 2 perpendicular vectors is 0. Have you got that? Remember when we had I dot I? These are 2 parallel vectors. These, of course, are unit vectors, but it holds for vectors which are parallel as well. If 2 vectors are parallel, their dot product will do what? 1. Do you get that?
Yes.
Yeah, I dot I is just 1. But if the vectors are perpendicular to each other, like I dot j, we know these 2 are perpendicular because if we're in the, this is y-axis, this is x-axis, they are perpendicular. Unit vector in the xi, unit vector in the yj. So if we have perpendicular like this, dot product is going to be 0. So the dot product of 2 perpendicular vectors is going to be 0. So in this check, we know to say for this to be a right-angled triangle, it means that 2 of its sides must be perpendicular to each other, right? So it means that either this and this are perpendicular, or this and this are perpendicular, or this and this are the ones perpendicular. So to check which pair is actually perpendicular, we are going to use dot product. In this case, we don't have to find the angle. All we have to do is show that the dot product of one side with this side is going to be 0. Again, it is still trial and error until when we find the pair which gives us 0 as the dot product. Let's try PQ, or PR and PQ. Is this the pair giving us a 0 dot product? We know how dot product works. It's multiplication of corresponding entries. So you have PR dot PQ. So it's -3 minus 6. That is going to be plus 18. Then we have +2 minus 3. That is going to be minus 6. Then next we have -6 plus 2. That is going to be -4. Guess what? This is the one giving us 0. Do you see that?
Yes.
So because of that, we conclude that PR and PQ are perpendicular to each other, meaning that the whole triangle is actually right-angled. So PR and PQ are the ones perpendicular. So even though we drew this very badly like this, but by dot product, we have seen that given the vertices, the angle here, alpha, is the one which is 90 degrees. Now between PR and PQ. So this is the 90-degree angle. So we conclude. So just by doing this, we have shown. So because PQ and PR dot product is equals to 0, it implies that, so I can actually even say that, because PR dot PQ is equals to 0, it means that PR and PQ are perpendicular to each other. Are perpendicular to each other, making our triangle to be a right-angled triangle. So this is how we would conclude this. The last part was to say find the area of that triangle. To find the area now, that is quite basic. The area here is going to be, since it is a triangle, you know the formula for area of a triangle. It's just L times B, of course, multiplying half of it. So here, this is going to be half but the next part is going to be a cross product, but of any two sides. Which sides you decide to pick, completely up to you. So it will have to be half. The cross product can be anything really, but we're going to get only its magnitude. So we can still get PR and PQ. So I can say PR cross PQ. So when you do this, this is what is going to give you the area of that triangle. Is that okay?